When you do recordings, you don't need to. I hope that doesn't affect you.
I teach a lot of things.
Like, I understand it much better. I'm sorry.
Well, yeah. When I'm recording it the second time around. So that's natural. That's why I record the second time around.
It's too late. Learning for experience. Really? I actually did.
What's that?
I said, did I actually get your feelings?
No, I said.
Okay.
It's sort of like when you take a test the second time and you better.
Much better.
It's human nature. All right, so we're gonna grab tangent, and then on Wednesday we'll grab cotangent. Friday we'll grab secant, and then next week, whenever it is you arrive, since you have choose out, we'll grab cosecant, and then we'll be done with the graph. For tangent, cotangent, secant, and cosecant, we're not going to do any shifting. We're not going to do any phase shifting. We're not going to do any vertical shifting. We're just going to deal with period and amplitude.
When I took math last year, they spelled it Tangeant. Yeah.
Me too.
Tangent.
That's how they used to spell it.
Tangent.
So but I had this with, so I
That's on.
Well, I don't care.
As far as I know, tangent is spelled that way.
Maybe because it's.
Like, there's different ways to pronounce Greek letters, like tau and ta. So some people say tau, some people say ta, so maybe it's one of those things. Some people say car, some people say ka. So I put asterisks next to this, but I'll circle it too because the period is different for tangent than sine and cosine. The period's pi over b. Okay, so amplitude, we will handle the same. We multiply the y values by whatever the amplitude is, and the period, we'll take b, we'll divide pi over b, and get the period. And the difference between tangent and the other two also is that it has asymptotes. It has asymptotes. So there are points. There are x values where tangent is not defined. So we'll have asymptotes. Asymptotes. So We're going to first graph regular tangent. So the amplitude is the number in front of tangent. It's 1. The period is pi over b. B is the number in front of x. So for plain old regular tangent, the period is pi. That means you're going to get one curve of tangent in a distance of pi. It's out here for public consumption.
Today's class.
It's a good thing I don't have a video camera. So to find out the location of the asymptotes, okay, and because we're not shifting tangent, tangent's going to be centered around the origin. To find the asymptotes, there's going to be one at the beginning and one at the end. So it's kind of like finding our start and our end. We take the period and we divide it by 2, and then there'll be one that's positive and one that's negative. So for regular tangent, there'll be an asymptote at minus pi over 2 and an asymptote at plus pi over 2. And in between it will be a curve.
Why does this have an asymptote?
Because there's parts, there are values, there are degree values and radian values that when you plug it into the tangent function, they're undefined. Like there is no answer. So pi over 2 is the same as 90, right? So the tangent of 90 is undefined. Tangent of 91 over, or y over x is 1 over 0. Division by 0 is undefined. And then to find the interval, we take the period divided by 4, just like we have been.
Wow, you're right.
Thank goodness I was telling you the correct thing.
Yeah, you did it. That's my
Okay, so we're going to start at negative pi over 2. We're going to end at positive pi over 2. Then we're going to increase by pi over 4. Okay, for us, for this class, we're not going to, like I said, we're not going to shift tangent, so it's going to be centered around the origin. So the middle number will be 0. And the other ones will be symmetrical. So if I have negative pi over 4 on one side, I'll have positive pi over 4 on the other side. So it's kind of nice. My asymptotes are at negative pi over 2 and positive pi over 2, so the y values there are undefined. We're going to have asymptotes, which we're just going to use dashed vertical lines. At negative pi over 4, we'll have a y value of negative 1. Tangent of 0 is 0. And then 1.
So for tangent, we can just give it the period instead of pi, it's just a pi.
So again, what's nice is we're going to just do the basic tangent, so we're not going to shift it. So it's always going to be nice and symmetrical. My asymptotes at negative pi over 2 and positive pi over 2 look like this. And if you don't draw them, the function is incomplete. You have to draw the asymptotes.
What was that? Stop.
Okay, and tangent is a curve. It's not a straight line, so please don't connect the dots and draw a straight line. I'm not going to give you full credit for that. It curves. The origin's a point of inflection, so it changes the way it curves. And it goes towards the asymptote, but will never touch it. So the period, depending on what the period is, this will get wider or it'll shrink and be tighter. Depending on what the amplitude is, these points will be further away from the x-axis. If it's negative, this thing will flip, so it'll go from this to this.
Do that again.
Okay. Questions about plane old tangent? All right, I want you to try that one.
It'd be pretty chill for you though. I think teaching pretty chill.
I don't think it's chill.
But they
Not necessarily.
But
they don't
Hey,
disrespect.
are there any questions about this? All right, good.
I'm pretty sure I'm a very big challenge.
like what?